I am Anil Kumar. Welcome to your YouTube channel. This is where your request and our solutions meet. Here we have a practice test question. We are going to identify all the divisors of the given numbers and complete the table. The whole idea here is to review divisibility rules. We'll explore these rules and also understand how do we apply them for different numbers. So to keep it simple, we are taking small numbers, only three-digit numbers we have taken. However, it is important to understand each and every rule. Divisibility by 2, by 3, 4, 5, 7, 9, and 11. So 7 is something which is least understood, so we'll lay more stress on that. So let's begin. You can always make a table like this, complete, and then check with my solution. So let's go with divisibility rule for 2. Now clearly, all these numbers which are even will be divisible by 2. So we'll identify all divisors for which the given number and they complete the table. So 132, we know it is divisible by 2, so we'll cross this out. So this is the 1, this is also the 1, and here we will not cross it out, we just leave it as such. 144 is even, this is also even, and that is even. So these are all divisible by 2, right? So I'm using like cross. Some people will use right. Some people may use right and cross both, and they'll put the cross on the other side, right? But for me, if I say this cross, or let me rewrite this as a right sign, that makes more sense, right? So let me change the color to green. Okay, so this is what I'm saying, divisible by 2. You agree with me? That's simple. Now let's get to divisibility rule by 3. So to check with that, we just need to add the numbers. 1 plus 3 plus 2 gives us 6, and 6 is a multiple of 3. 5 plus 4 is 9, that is also a multiple of 3. 4 plus 5 is 9, and then we have 9, that also works. 144 is also totaling to 9, that also works. 4 plus 2 is 6, it is divisible by 3. 6 is divisible by 3, 9 is divisible by 3, and also 3. In this particular case, it is also divisible by 3 and 924. 9 is divisible by 3, 2 and 4 is 6, so that is also divisible by 3. Great, so we got it right. All right. Now for 4, what we need to do is we need to only check the last two digits, correct? So that is what we have to check for each to be divisible. And of course, it has to be even also. So we need not worry about those which are not divisible by 2, right? So that helps us. Okay, great. So with 4, 32, 8 times 4 is 32, 52, 13 times 4, 95, of course, will not work for us, 44, 11, and 20 is 4 times 5, 24 is 4 times 6. In this case, all those which were divisible by 2 are also divisible by 4. But that is not the case each time. You understand? Okay, great. 5. We're only looking for 5s and zeros. So we got two of them here. Right. So that's easy. Third one also, 315. So we got these three divisible by 5, where we are only looking at the last digit, whether it is 0 or 5. Makes sense, right? Now it is time to work on 7. How do we figure out 7? That is kind of difficult. So in 7, the rule is okay, we'll come to 7 at the end. Let's do 9 and 11 first. Okay, so we'll come to 7 at the end. Let's take up 9. 9, the sum should be divisible by 9, or sum should be multiple of 9. So let's do that addition once again. which we did for 3. So 1 plus 3, 4 plus 2 is 6, which is not, so this will not be there. And the next one is 5 and 2, 7 and 2, 9. This works, right? So addition 9. 9 and 5 and 4, 9, correct. 4, 4, 8 and 1, 9, it works. 426 doesn't work. 4, 9, okay, 6, 9, 3, it works. So 693 works. 315. So 4 plus 5, 9. It works. So we just split and add, correct? 9 works, 24 does not work, so leave it. Great. Let's do 11. So in 11, the sum of alternate digits difference should be multiple of 11, right? Hmm. So 1 and 2 is 3, and in between we have 3, it works. 2, 2, 4, it doesn't work. 4 and 5 is 9, and we got 9 in between, that works. 5, this will not work. 4 and 2 does not work. 6 and 3, 9 and 9, this works. And here we have 5 plus 3 is 8, it won't work. 5 and 4, 13, and 2. So 13 and 2 works, right? Because 2 plus 11 is 13, right? So this works. You see that? You may check at this moment why it works. See, if I add 9 and 4, it is 13, right? And 2 plus 11 is also 13. So therefore it works. You understand? The rule of 11, it could be same or a multiple of 11. So that is how it works. So that is true. Now let's get to the main challenge, and that is divisibility rule by 7. So the rule is you have to take away the last digit, twice it, double it, and then take away from the number. So let me explain. In 132, let's write the number 132, right? So from there, take away 2. And what is twice 2? Twice 2 is 4. So difference of 4. So 13 minus 4 is 9. And this should be multiple of 7. It is not a multiple of 7. So it will not be divisible by 7. Next number, 252, right? So in this case, what we are going to do, remove 2 from here, twice it, and subtract, right? When you subtract, you get 21, and we get 7 times 3 as 21. So this number is divisible by 7. You get the whole idea, right? Now we'll take another one, 495. So 495, 5, double it. So when you double it, you get 10. Take away 10, you get 39. This is not divisible, right? It doesn't work. 144. So 144, drop 4, double it, take away, right? So 8 times 6, 8 and 6 is 14, so that also doesn't work. 420. So in case of 420, drop 0, double it, it is 0. So 42. 6 times 7 is 42, so that works. You get the idea, right? 693. So for 693, drop 6, take away, drop 3, double it, which is 6, take away. So we get what? 63. And we know 7 times 9 is 63, so that also works, right? You can check your result. 315. So 315, drop 5, take away 10, which is double the 5, and we are left with 21. That works. So 315 is also divisible by 7 without any remainder, right? 924. So for 924, 4 twice is 8, take away 8 from 12, we get 84, and 7 times 12 is 84, so it works, correct? So these are all the numbers which are divisible by 7. You see that? So that is how we can complete our table. We have put the check marks only for those which are divisible by the given set of numbers, right? So I hope that makes sense. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your valuable time and all the best.